Hello guys, welcome back to the course. In the previous video, we've already performed data augmentations, and now in this video, we are going to retrain the machine learning model using that new data. Okay, let's get started. Firstly, we are going to create a new project folder. I'm going to name the folder Retrained. And let's open VS Code. And we are going to open the project folder. So let's click open and let's open retrained folder. Let's click open. Next, we are going to create a new file. I'm going to name the file retrained machine learning model.py, and obviously we are going to save this file inside the project folder. Let's click create file. Okay, next we are going to import several Python libraries. Firstly, we are going to import OS or operating system. Next, we are going to import pandas. We are going to use this library for loading the datasets. Next, we are going to import train test split from scikit-learn.model selections import train test split. We are going to use this library to split the datasets into training and testing sets. Next, we are going to import random forest classifier from scikit-learn.ensemble import random forest classifier. This is the machine learning model that we are going to use. Next, we are going to import accuracy score and classification report from scikit-learn.metrics import accuracy score, classifications report. We are going to use these libraries for evaluating the model's performance. Next, we are going to import label encoder and standard scaler from scikit-learn.preprocessing import label encoder, make sure it is uppercase, and standard scaler. And lastly, we are going to import NumPy. Next, we are going to define the file path for the project folder. So let's create a new variable. I'm going to name it base dir or base directory. Okay, let's open terminal, and we are going to drag the project folder to the terminal, and we're going to copy and paste the file path. And let's go back to VS Code, and let's put the file path right here and make sure there is no space. Okay, let's continue. Now we are going to add the real datasets path. Let's create another variable. I'm going to name it real data path. You can name it whatever you want. It is totally up to you. And in this case, we are going to use os.path.join. And let's copy and paste base directory, and let's put it inside the parentheses. Next, we are going to copy and paste this dataset, earthquake alert balance datasets, and we're going to put it inside this project folder. So make sure the dataset is inside the folder. Inside the parentheses, let's put the name of the dataset, earthquake alert balance datasets.csv. Make sure it is the correct file name. Next, we are going to add the file path for the augmented datasets. Let's create a new variable. I'm going to name it augmented data. And we are going to use os.path.join, and let's put base directory inside the parentheses. And for the new file, we're going to name it new data.csv. Okay, next we are going to load the original datasets using pandas. Let's create a new variable. I'm going to name it realdf. So this is like the original datasets. And we're going to use pd.ratecsv. And let's copy and paste real data path and let's put it inside the parentheses. Next, we are going to clean the column names. Let's copy and paste this realdf dot columns and let's create a bracket col dot strip dot lower, and we are going to create a for loop for col int realdf dot columns. Next, we are going to print the confirmations message loaded real dataset, and we are going to display the path. So let's copy and paste real data path and put it here. Next, we are going to display the first 5 rows of the datasets. Print realdf.head. Next, we are going to create a conditional statement to check if alert column is categorical. If realdf, and let's put alert inside the bracket because we want to access data from this column, dot dtype, because we want to check the data type of this column, is equals to object. Then we are going to initialize label encoder. So let's create a new variable. I'm going to name it LE. And we are going to utilize this library, label encoder. Let's copy and paste that. Then after that, we are going to encode the labels. realdf, and let's put alert inside the bracket. And we're going to use the label encoder. So let's copy and paste LE dot fit transform, and let's copy and paste this and put it inside the parentheses dot type, and let's put str or string inside the parentheses. Next, we are going to print the encoded label classes. Print /end encoded alert labels list le.classes. Else, we are going to make sure the alert column is in numerical type. realdf, let's put alert inside the bracket, and let's copy and paste this dot type, and let's put int or integer inside the parentheses because we want to make sure the data type is integer. Okay, next we are going to perform data augmentations. But if you remember, in the previous video we've already performed data augmentation, so we're going to copy and paste the code, guys. Let's copy and paste this and let's put them here. We are going to modify this code a little bit. We're going to remove this line because we have already loaded the dataset. So let's remove this line. Next, we are going to replace data with realdf. Next, we are going to replace new data CSV with augmented data file path. So let's copy and paste this and put it here inside the parentheses. Next, we are going to print the confirmation message. Let's type in augmented dataset saved to augmented data path. Next, we are going to display the first 5 rows of the augmented datasets. Okay, let's continue. Now we are going to merge datasets and find common columns. Let's create a new variable. I'm going to name it common columns. You can name it whatever you want, it is totally up to you. And we are going to create a for loop. C for C int augmented df dot columns if C int real df dot columns. Next, we are going to merge the original and augmented datasets. Let's create a new variable. I'm going to name it merge df. And in this case, we are going to use pd.concat. And let's create a bracket inside the parentheses. And let's put realdf. And let's copy and paste common columns and put it inside the bracket, comma, augmented df. And let's put common columns inside the bracket. And we are going to set ignore index to true. Next, we are going to print the merged dataset shape. Print /end merge dataset shape. And let's copy and paste merge df dot shape. Next, we are going to define the filter columns and also the target variable. Let's create a new variable. I'm going to name it x. And let's copy and paste merge df. And in this case, we have 5 filters. The first one is magnitude. The second one is depth. The third one is CDI. The fourth one is MMI, and the fifth one is significance score. And let's create another variable. I'm going to name it y. And the target variable is alert. So let's put alert inside the bracket. So in this case, x represents the filters and y represents the target variable. Okay, now we are going to encode the labels if it is still categorical. Let's create a conditional statement. If y.dtype is equals to object or string, then we are going to encode the label. So we're going to initialize label encoder. Let's create a new variable. I'm going to name it ley. You can name it whatever you want, it is totally up to you. And we're going to utilize this library, label encoder. Let's copy and paste that and put it here. Next, we are going to transform labels into numerical format. Ley.fit transform, and let's put y inside the parentheses. Next, we are going to split the datasets into training and testing sets. We are going to create 4 variables. The first one is xtrain, the second one is xtest, the third one is ytrained, and the last one is ytest. And we are going to use trained test split library. So let's copy and paste that and put it here. Let's put x and y inside the parentheses. Remember guys, x is the filter and y is the target variable. Next, we are going to set the test size 2.2. 80% of the data will be used for training and 20% of the data will be used for testing. And lastly, we are going to set the random state to 42. Okay, let's continue. Now we are going to initialize the random forest classifier model. Let's create a new variable. I'm going to name it model. And we are going to utilize this library, random forest classifier. Let's copy and paste that. We are going to set the n estimators to 100. And we are going to set the random state to 42. Next, we are going to train the model using the training data. Model.fit, and let's put x trained and y trained inside the parentheses. Next, we are going to make predictions on the test set. Let's create a new variable. I'm going to name it ypred. And we are going to use model.predict. And let's put xtest inside the parentheses. Next, we are going to calculate the accuracy score. Let's create a new variable. I'm going to name it accuracy. And in this case, we are going to utilize this library, accuracy score. So let's copy and paste that. And let's put ytest and ypred inside the parentheses. Let's copy and paste this and put it here. Next, we are going to print the completion message. Print /end model retraining is complete. Next, we are going to display the accuracy score. Print accuracy. Let's copy and paste this and put it here. And we are going to round this up to 4 decimal. So let's add 4f. Next, we are going to print the report header. Print /end classifications report. And lastly, we are going to display the classifications report. So let's copy and paste this and put it inside the parentheses. And let's put ytest and ypred inside the parentheses. So let's copy and paste them and let's put them here. Okay guys, we are done. Well, actually there is one more thing that we need to do. We need to save this new model. Okay, now we are going to import joblib. We need this library to save the model. Import joblib. Next, we are going to define the path for the new model. Let's create a new variable. I'm going to name it model path. And we are going to use os.path.joint. And let's put base directory inside the parentheses. And I'm going to name the model new model.pkl. That's the file format. Next, we are going to save the model using joblib. Joblib.dump. And let's copy and paste model and put it inside the parentheses. Next, we are going to specify the model path. So let's copy and paste model path and put it here inside the parentheses. Okay, now let's save the file. Just click File and click Save. And we are going to compile the code. So let's open a new terminal. Firstly, I'm going to clear the terminal. Next, we are going to access the project folder. So let's type in cd /user/Chris Aldica, that's my username, /desktop/retrain, that's the project folders. And let's type in Python retrained MLmodel.py because that's the name of this file. And let's hit enter. Okay, it will take few seconds. The accuracy score is 0.86 and here is the classifications report and here is the augmented data. Okay, now let's open the project folder. Let's click this. As you guys can see, now we have the new data. This is the augmented data and we also have the new model. So in this case, we perform data augmentations, we got this new data, and we use this new data to retrain the machine learning model. Okay guys, I think that's it. That's all you need to know. I'll see you guys in the next video. Bye.